Everyone, welcome to this channel. Today's problem was quite interesting. It is the diagonal difference problem on HackerRank. Although this is an easy problem, it took me quite a while to solve. It took me about an hour. And after I look on other people's solution, I found an ideal method of solving it. So I want to share it with you. So this is the problem. Supposing you have a 3 by 3 matrix, what you are supposed to do is you are supposed to sum up the leading diagonal and the trailing diagonal. After you sum up those two values, you find the absolute value, which will in effect give you the determinant of the matrix. So that's what the task was about. So if you look at this matrix, 11, 5, negative 12, the leading diagonal, you sum it up, you get 4. Then 4, 5, and 10 are the trailing diagonal, which if you sum, you get 19. Then you do 4 minus the sum of the leading diagonal minus the sum of the trailing diagonal. After you've done the subtraction, you find the absolute value, which will give you 15. So this is how I went about solving the problem. First, I went to the board, I drew examples of various matrices. So I did a 2 by 2, 3 by 3, and a 4 by 4. After that, I look at the difference and realize that the leading diagonals are values which are the leading diagonals are all the numbers that are separated by +1 of one side of the array. So if you had a 3 by 3, if you had a 3 by 3 matrix, you take 3, the value 3, and add 1 to it, so 4. So the leading diagonals are separated by counting 1, 2, 3 from position 1, 2, 3, 4. You get the middle one, then go 1, 2, 3, 4. You get the last one. Then for the trailing diagonal, all you do is you take the length again. So if it is 3 by 3, subtract 1, you get 2. Then you start counting 1, 2. Then you go 1, 2, you get to the middle, 1, 2, you get to the last one, which will give you the trailing diagonal. So this I implemented it in the code. First, I wrote a for loop which took in all the values in the matrix. So 2 for loops over here. They take for each value in the matrix, you append it to a new matrix which contains the whole. So in effect, I'm changing the matrix to a list of numbers. Then I use another for loop over here to loop through. So I check if, let's say if it's a 3 by 3 matrix, I know the length of one side is 3. So I take that 3 and I add 1 to it. Then I check if it is actually a multiple of 3 by using the modulus operator over here to check if the remainder is there. If it is, then I add the value right here. And I did same for the trailing diagonal. In this one, I subtracted 1. So if I subtract 1, this will give me each element. But I noticed something. It also added the first element. So I use this operator to remove the first elements from the matrix. And also it added the last one. So I also use this condition right over here to remove the last element from the list. Then that will in effect be my trailing diagonal. After that, the rest is I use the absolute function to get the absolute value, leading minus trailing right over here. So this is how I solve it. It took me about an hour, surprisingly. A lot of trial and errors. Okay. So if you run this code right now, it should work. Okay. So that's it. It works. Even if I submit it, it should pass for all the cases. But look at, yeah, so that's it. Within some minutes, it's finished running for all. But I think this solution is not ideal. We have about 1, 2, 3, 4 loops running here, which is not ideal. It will increase the time it takes the program to execute. So after I submitted and passed this challenge, I went to look at a friend's own. He was also solving the same challenge, Polymoke. I look at it and then I realized I could make the solution better. What he did was, for his code, what he did was for the leading diagonal, they always have the same elements. So if you have a 3 by 3 matrix, 0 0 0 0 1 1 2 2 will form the leading diagonal. So to implement it, first I found the one length. Since it's a matrix, I just took one of the arrays and found its length, which should give me the size. So if it's a 3 by 3 matrix, using picking only one of the elements in the matrix and finding its length is going to give me the, like, it's going to give me 3 if it's a 3 by 3, and if it's 2 by 2 to give me 2. Instead of using this long method I was using over here, I use the square root of the length plus one, a lot of things which is not ideal. But just using this way got me the side a single dimensions length. After getting that length, what we did was we now iterated over that length. Then we append each element that has the same I. So if it is 0 0, we append it to leading. The append function puts an element inside a list over here. So 0 0 1 1 2 2, all of them will form the leading diagonal. They get put inside this leading variable. Now for the trailing one, what you realize also was that for the trailing one, it's also the I for each element. Okay, so it goes I. But this time around, it starts from the length of the dimension. So if you have a 3 by 3 matrix, it will start at 0 3. In this, if it is in the array, it should be 0 2. So 0 2. Then it will go again to the next line, but this time around it's going to shift and come down. So have let's say 0 1. Then if when we go to the next element, yeah, so I think this is 1, yeah, 1 1 1 instead, sorry. So let's go again. You have a 3 by 3 matrix. I'm going to represent the positions as 0 0 1 2 0 1 2 0 1 2. So the first one will be 0, then followed by 2. So it will be the element here. Then the next one will be 1, and then we'll subtract 1 from these two. So have 1 1, which will be the middle one. Then the next element will be 2. But to subtract 1 from the 1 here, so we'll have 2 0. This will give us a trailing diagram. And to implement it, this is what I did. For each element in the array, I pick the position, which can be 0 1 2, and then the trailing shifter, which is simply a value that is equal to the length of a single dimension. Now, upon each iteration, I subtract 1 from the length of the array so that it will be shifting downwards like that. So that's how I solve this problem. And I use the sum function to sum all the values in the list, both for the leading and the trailing as well, and then return the absolute value. When I run the code, it passed also. So if I submit the code, it should also pass. So that's it. It passed right there. But this solution could be improved a step further. Having this trailing shifter variable could be removed. So I reiterated on that and removed the trailing shifter variable to be just this. So over here, I get the length of the array if it is 3. Then we move to the I. I subtract the I and then subtract 1 from it. And this always gives us the value as if it is coming down like that. So using this was the optimal solution I've found that worked. So let's submit and see. Yeah, that's it. It runs very fast. Only from about one, two, three, four loops to only one for loop. This is awesome. I really enjoy HackerRank. If you are not yet there, I'll urge you to sign up. Okay, so that's it, guys. See you later.